So let's begin. This is TOCS, Talk on Computer Systems. It's a regular event of Carnegie Mellon. Silicon Valley. We like to invite people from around the valley to come and tell us about the wonderful things they're doing. It's a pleasure to have Dr. Stan Rosenchein here. We have worked together over this last year, and actually longer, on coordination technologies, both for small groups, personal interest, and possibly for some of the larger things related to disaster management and so on. He's a former director of the AI Center at SRI International and also affiliate to Stanford University Computer Science Department, founder of Branch Time Technologies and other technology companies, and he's going to tell us about the exciting things you do to coordinate with others.
Thank you very much. Pleased to be here, and thank you all for coming. I'm going to talk today about coordination, and I hope by the end of the talk we have arrived at a slightly different view of what coordination is and can be. There's a lot of ambiguity out in the world, and especially in the world of commercial products and tools, on the differences between coordination, communication, collaboration, some words like that. I'm not going to propose hard and fast boundaries between them, but I hope that you'll start to get the idea of what we have in mind when we say coordination. And specifically, I'm going to talk about a vision for a future world of coordination in which the open internet has built on top of the communication layer that we now enjoy, which includes email and messaging and social media and voice communications, another layer which has a bit more structure that's specifically designed to foster coordinated activity. And what I'm going to talk about today are some of the principles that might go into the design of something like that and some tools that might be part of it. You might say, well, why do we need a coordination layer? And I'll make an analogy here with the transportation system. If you think about the internal combustion engine and cars, and imagine that the whole world were just paved with asphalt, and you gave everybody a car, and you said, good luck, proceed to your destination. If you were the only person on the road, that may not be too bad. But if there were a lot of other people there, you're not going to get very far, because things like modulating your rate of speed and rights to go and things of that sort require coordination with other people. So we have an elaborate system to coordinate our road activity. It includes signs and laws and lanes and signals and embedded sensors and a lot of things. And all of that is really just so that we can share the road in a way that's productive for all of us. If you look at the world of online collaboration and coordination, we're more like the open parking lot in the sense that we have a lot of communication tools and people are sending messages wildly to each other, but those signals don't necessarily have the intended effect. So there's a lot of redundancy and there's a lot of frustration around what the relationship is between that message traffic and all that communication and specific progress on activities that people are carrying out or trying to carry out together. On the other hand, we don't want something that's overbuilt, because we've all had the experience of using workflow systems or other elaborately designed tools that were intended to make us more productive but actually had the opposite effect. They slowed us down, required a lot of data entry, people ignored them, or they weren't sure what they were supposed to do for them in the first place. So somehow we have to walk that middle ground. I'm going to start off by talking about some areas that are outside the conventional workplace, because for us, these are really more the leading case. When we think about coordination on the open internet, we really have in mind the open internet. If you use email as an example, there are 2.4 billion email addresses in the world, and anybody in the world who knows how to fill in a to-field or hit the reply button can send an email to anybody, and that other person, regardless of whether they're using the same email client as the sender was, can interoperate with them freely and understand what to do and do a reply or certain stylized operations. That's the level of interoperability that we would like to see in the world of coordination. So we're not starting with the idea that we're looking inside an enterprise or a particular work group or something like that. We're really looking broad. And the interesting thing about that is that a lot of the problems that people face in different areas that actually have important consequences for them are perhaps being underserved today because of the fact that they're being addressed by institutional actors, what I was calling institutional actors, who are able to enforce institutional norms or behavioral norms on the people who are affiliated with them, but their influence drops off sharply at the institutional boundary. So when we're envisioning a world where that boundary is opened up and a lot more coordination can happen across that boundary. And I've listed about half a dozen here. We can go into more particular use cases, but I've mentioned a couple just evocative examples of good and bad. So in healthcare, if you look at sort of what's the primary benefit that each of these areas is trying to deliver to the individual, in healthcare, obviously the bad would be a medical crisis or worse. The good is disease prevention and management. In education, if a student goes to college, for example, and he drops out because he hasn't developed the self-management skills, he's not staying on top of his work, that's bad. If he graduates and he's gaining education, that's good. In the case of the workplace, if a person is looking for a job and can't find a job or doesn't fit in with the job requirements of a particular organization, or there's not a good slot that he can find for himself, that's bad. If he has a job and he's functioning well, that's good, and so on. And yet, the institutions that are meant to influence these processes are coming at it from a single, rather narrow angle of approach. A lot of times, the real set of actors that could have an influence are not necessarily the ones who represent the institutions, but rather sort of a para group or an ecosystem around the individual that includes family members, that includes social contacts, people in the community, and who knows who all. And the interventions are not the kind necessarily that these formal actors can accommodate. So that's kind of the interesting case for us. How do you build clusters of activity and people that float free of these institutional boundaries, hierarchies, and stylized behavior patterns, okay, and that are lightweight enough and interoperable enough that eventually the whole planet can agree on a common set of them. So that's kind of the starting point. That's the starting question. And here's another illustration of it with a little cartoon Leonardo man. And the point that we're trying to make here is just that an individual is the nexus of all these different areas of his life. So these institutions, although they may define specialized forms of interaction with that individual really needs to navigate across all those different areas. And it's not necessarily convenient for him to be jumping to 14 different websites, each of which has its own style of interaction, its own things that they're trying to get him to do, and so on. He is the nexus. He's the convergence for all the attention and action. And his ability to manage that is going to be part of his challenge in how to succeed in all these different areas of his life. And even more so as the world becomes more networked and more decoupled and more granular. We can go into particular examples of that from different fields. But even in the education field, for example, if you have a lot of online content and people aren't localized in brick and mortar institutions anymore, then self-management and the ancillary activities that go along with getting an education become that much harder to manage, and it puts a lot more burden on the individual to maintain that ongoing activity with the people around him. So what's wrong with the communication layer for doing coordination? After all, it seems in some kind of Turing sense to be sufficient. It seems like if you can send email messages and you can do voice communication, you could coordinate with anybody you need to coordinate with. Just send them a message and say, can you do this thing? And they send you back a message and say, yes, I'll do it. What is the big problem? The big problem is that those are not the issues so much. The actual raw exchange of information is not the issue. There's actually a set of patterns around the accomplishment of tasks, the interleaving of multiple tasks that you're trying to juggle at the same time, the constant interruption and resumption that you need to do in order to accomplish a task that has breaks in it and it depends on other people. And that introduces a whole new level of complexity, and we need a new set of concepts so that we can build tools that recognize those. I mean, we've all used email for coordination, and we've all run into its failure modes. So let's kind of unravel this a little bit and ask the question, well, what is coordination in the first place? If you think about action, and you think about the basic parameters that define activity, these are some of the questions that define what it means to coordinate. Answering questions like who does what when sounds very simple, right? Who knows what when? In other words, who has received what information by what point in time? And who decides A, In other words, who decides who does what when, and when does he decide it, right? Or who decides who knows what when, and when does he decide it? And then E, F, G, H, I, J, K, all the recursive elements of that. So if you think about the cluster of decisions that would define a collection of activity, there are these many open questions right off the bat. And each of these introduce some amount of uncertainty potentially, or some amount of vagueness. For example, if you get an email message requesting that you do something, but the actionable bit is buried deep in that email message, then by the time you parse the message and figured out, okay, what do I in my role need to do about this message, if anything, okay, that creates a lot of task vagueness and maybe role ambiguity. When do I need to do something about it? Maybe it wasn't mentioned at all. When do I need to touch it next? In other words, when do I need to engage with this task next? Not necessarily clear. And every one of those questions forces me to make a decision, or by default, make a decision to not touch it for some period of time. And often what happens is that these vaguenesses get cleared up, but only at great effort, and maybe sometimes too late, or in a way that's not opportune. So, for example, if I get an email asking me to do something and I figure, okay, I'll get to that, and I let it drift down in my inbox, and then a week later, the person who sent me the email says, where is it, right? I should have engaged with that task several times over. Maybe my personal organizational system wasn't up to the job because I had dozens or hundreds of other things I was doing, and so on. So these are the cluster of questions that define the coordination problem as distinct from just exchanging information, right? And to do coordination right, the contention of this talk, at least, is that we need some new foundations. And I'm going to divide those into conceptual modeling elements and architectural models. And I'm going to mention a few of them here and then walk you through some examples. So on the conceptual side, the first thing we're going to start with is distributed intentional state. And what that really has to do with is not just that we have a network in which we know people, let's say a social network in which we know people, and with whom we exchange information, but rather we have a network of people who are committed to doing certain things for their own reasons or because they've promised other people to do it. There is a distributed intentional state that the people in that network share. And for subsets of them, they actually know that they intend to do it, and they know that they know to intend to do it, and so on. So let's call that the distributed intentional state. Protocols define transactions that update or modify or move forward that intentional state. And if that's done in an orderly way, it's done in a way where there's no, or at least minimal, ambiguity on the parts of the participants in that state who are trying to coordinate their activity on what the new state is, because they've all observed the protocol and they've done these transactions in a more stylized way. And then finally, the behavioral model, and that has to do with attention management. Namely, what is the frequency and what is the reliability with which we can guarantee that people are going to engage with a given task, and how much support does that individual have with that process of engagement? We see that as essentially a partnership between the individual and the personal habits that he adopts and the tool that he's using. And we'll introduce a new kind of tool that we hope will give a very congenial kind of partner for that sort of recurrent engagement. Okay, so we'll call that the behavioral model. On the architectural side, what you really want to do is you want to build an architecture which will support the conceptual model as cleanly and as elegantly as possible. The architecture that we're going to describe here includes a centralized, although it could be federated, set of coordination services, individual personal touch points that would be clients that an individual would use to interact with that representation of the distributed intentional state. And these come in several categories, and one in particular I'm going to call your attention to, and that's prompter. That's probably a term that you haven't heard in a context like this, but it refers to as essentially a personal coordination assistant that will engage your attention around items that require your attention and provide affordances to help you move that task forward, whatever it is. Okay, we're calling that device a prompter. We have a particular behavioral model in mind for how people will use that prompter and in what frequency they'll use that prompter. But it's not, it's a twist on the way people use their cell phones now or their smartphones, for example. But in addition to the prompter, we imagine other ways that people could engage with this distributed task network through conventional software tools or through conventional websites or web services that would allow them to interoperate with that distributed intentional state so that it wouldn't matter where they created the task from or where they received the task from, they could still examine it and transact with it from other contexts as well. And then finally, what we envision this to really be is kind of the beginning of a new style of, I wouldn't say programming necessarily, because when you say you want to program people, that sounds a little bit big brothery, but I would say more like social process design. And the idea is basically this. If you have a reliable platform and an execution model, which on a statistical basis, you may not know exactly what everybody's doing at every given moment, but there's a certain rhythm to the way the tasks are being unpacked, shared, updated, communicated about, performed, completed, and so on. If that is a predictable flow, then you could imagine a level of social process design on top of that that would deal with the art and science of how do you deploy complex processes that would live and develop organically on that substrate. And methods libraries and templates and things like that, what I'm going to show you is geared towards capturing bits of procedural guidance, right? You might think in the medical domain, for example, of checklists. You've heard of things like that, and nudge, and so on and so forth. You can develop objects which are more directive than just a suggestion that, hey, why don't you do such and such? It actually spells out more of the details. But on the other hand, is not fully determinative a way a rigid workflow would be, something that's more in the middle, okay? Now, let's go back and talk about action-oriented social networks. And now we're talking about the distributed state. What I'm going to describe here is just a little cartoon version. And to understand this, you just need a few basic concepts. And action, when we use the word action, it'll be synonymous with task, promise, commitment, intention, in some cases goal, whatever. Think of it as something that an individual intends to make happen in the world, okay? The action isn't just the physical action that he performs in the world, but the mental representation of the thing which he wants to bring about in the world, okay? The owner of the action is the person who has responsibility for making that thing happen. The stakeholders are people who are affected by that or who have some expertise, they have some stake in that activity, and who have the ability to see its state and who have the ability to exchange communication with the owner and with each other. A handoff is a transfer of ownership, so there's an orderly process by which ownership is handed off from one person to another. And in this model, that's a two-step process. I should also say that in this model, there's always a unique owner for any task. There are no orphan tasks, and there are no co-owners, right? Every task has an owner. I should say that that's also just a formalistic notion, because in actuality, one of the stakeholders could have prime position. And for all we know, the stakeholder is just calling the shots, and the owner is just saluting and saying, yes, boss, and doing them. But all of that is in the pragmatics and not in the stylized format. So the format says there is one owner. If you formally want to make somebody else an owner, you do a handoff. You say, do you want to do this thing? And the other person says yes, he accepts it, or he declines it, or he has a side conversation with you until he eventually accepts it or declines. At any time before the handee accepts it, the original owner can pull it back. In other words, he can cancel the handoff. So that's a very simple little game. You can just think of it as a stylized interaction. The action feed is a set of tasks that are queued up for attention, and the watch list are things that a stakeholder is looking at. So here's like a little simulation. So Alice decides that she needs to draft an announcement. She creates a task. She invites Bob in as a stakeholder. He gets to see that. They can exchange communications. And this history includes all the system events like create, share, et cetera, but it also includes live communications between them. Not live. In this case, it's asynchronous communications. There is a provision for synchronous as well. And she can add additional stakeholders and so on. She decides she's going to go away on vacation, so she initiates a handoff to Bob, okay? And then Bob says, sure, I'll do that. At that point, Bob becomes the owner. By default, she becomes a stakeholder. She may also have created another task or have been invited to be a stakeholder on another task by this owner over here, okay? So this is a network that's multiply connected in different ways, and there are two kinds of objects in this network. There are activities that are persistent activities. They have a life that progresses over time, but they are a locus of that activity, a place where these individuals can see what's going on. And by the way, this structure is not unique to this architecture or tool that I'm describing. You'll see that in many other places. I'm just trying to abstract out that feature of it when I'm describing this concept of a distributed intentional state. And if you look at this from the point of view of a given individual, all of the things that they're involved with, right, and all the people who are involved with the things that they're involved with constitute their neighborhood. That's their little universe. They don't have any visibility into the rest of the network because these people may be involved in other things and so on. So there's no direct notion here of a second order or a third order visibility relation. This is their neighborhood, and this is what they're trying to advance and make progress on. Okay. If it's a task that they own, their job is harder because they have to actually think of activities that will, in the real world, that will move the thing forward. Whereas if they're a stakeholder, generally what they're doing is they're just offering advice or communications. Sure. So when we get to the architecture and we talk about relations on these tasks and how they're spawned and so on and so forth, one could elaborate and make more structure there, right? At this level, this would be true even if there were internal logical structure among the tasks, right? These are still things that they're connected with, so I've abstracted that out of this description, but it doesn't mean that you couldn't layer that augmented structure on top of this, okay? I just didn't include that as a basic operation for purposes of illustrating this topology of the network, which is really my focus right now. Okay, and in fact, let's look at this diagram here. You can think of this as kind of a snapshot of the active network. And unlike social networks that you may be familiar with, like Facebook and LinkedIn and so on, most of those networks are really about people connected to people and data being pushed from the individual at the center to the people immediately around them. Those networks tend to be cumulative. You know, you may defriend people or unfriend people on Facebook, but I bet you haven't done very much of that. Who here has unfriended 5 people in the last week? Nobody, see? Well, right, I'm being facetious, but the fact is those networks tend to be cumulative. In fact, people take pride in the fact they have a lot of friends and their friend list is growing all the time. This is not that way because this has to be geared to people's cognitive bandwidth, right? Because these tasks are ones that you're going to be engaging with recurrently. So there's an equilibrium that you want to maintain for your tasks. If you're creating or acquiring or sharing tasks on a daily basis and you're getting 20 new tasks, you want to be disposing of 20 tasks a day too, because otherwise you can see what's going to happen. You're going to have a lot of tasks you're never going to do. Well, some people actually do have a lot of tasks that they're never going to do. But in this system, what you would be encouraged to do is to mark them as things that you don't intend to do, right? Or downgrade them in some way so that you can actually be realistic about how you map your available time to the claims on your attention, right? And so that needs to be part of the mindset when you design architectures and processes around these, namely that it's a very dynamic state. These tasks are coming and going. Maybe the people that you know are cumulative. And maybe if you define a social friendship relation based on people that I've been co-stakeholder with on a task, you know, that's a perfectly fine binary relation on people, right? If you consider that to be the set of friends, people that have ever been a co-participant in a task on, that will tend to grow cumulatively. But the actual tasks that you're involved with at a particular moment is intended to be bounded, and these relationships will be changing all the time. And you should also imagine that for each of these tasks, there's a little comment stream that's appended to it that's accumulating information about this task. But eventually, it's going to reach a final state where it'll be checked off, archived, and you can move on with your life. So that's kind of the topology. Now let's talk a little bit about architecture and talk about what kind of system could one build that would have the following properties. That it would maintain a fairly simple distributed intentional state for a fairly large number of people, like everybody on the planet, but that people could engage with from a variety of touch points, right? And but that they would also engage with on a reliable enough basis at a high enough frequency that other people that were depending on them could count on them doing their bit on an ongoing basis. So this is an architecture that's proposed. Up at the top here, there is a coordination process server, and the purpose of the coordination process server is to hold the task database, including all of its state of who the stakeholders are, what its status of completion, the comment stream that goes with it, and all the other historical information like when it was created and so on. I also mentioned the word call there because we're treating synchronous communication and asynchronous communication symmetrically in the architecture, in the sense that the architecture will actually have facilities for managing people's synchronous connection, so that if you want to ask somebody to participate in a call, say, you can just enter that request through the system, and you can offload to the system a lot of the mechanics of how that happens. And I'll show you how that happens when I talk about the prompter. But that's one of the attributes up here. If there is no coordination data server, then the data about the tasks themselves and the comment stream would live here. Those are text strings. And finally, there's the recommender engine. The recommender engine is the part that would use analytics, basically, to analyze the dependencies among the tasks and to analyze behavioral properties of the individuals and how they engage with the tasks in order to make recommendations about which tasks require their attention and on what frequency. Okay, that's living up here in the coordination server. Down here at the user level, right, we have this mobile prompter, browser-based prompter. These are both instances of a prompter. A prompter is basically a device through which you interact with the task database or the intentional database. And essentially, the model is this. You're not living your life with your prompter constantly open, waiting for things to come in, right? That's kind of old school. Old school is where, you know, you're constantly checking your email, you're constantly waiting for the phone to ring, and you're being bombarded with isolated requests for your attention, right? Kind of service requests, if you will. Continuous partial attention, right? You can receive one of those at any time, and there's some unknown response urgency about it. Here, the idea is you engage with this prompter on a periodic basis, and that periodicity is determined through a simple negotiation between you and the coordination server. So the coordination server is going to make recommendations. That's one of its recommender functions about when you ought to next come online, and it'll have various criteria for doing that. And you can say yes or no, or you can choose a different time. And so you have this negotiation, you commit to a time. Your prompter will remind you of that time, but then you can say go away. So it's this little double opt-in thing, right? At least that's the way it's designed to work. But when you're in this session, you are deep in task engagement, administration, housekeeping, update mode. You're not necessarily doing the task. You're looking at a description of the task. You're noticing, is it done? Do I need to spawn a subtask? Have I received any messages from the stakeholders about this task? Should I transfer ownership of these tasks? These are all transactions you can perform against the representation of a task without doing the task. The task might require an hour of your time. You're not going to do the task while you have your prompter open. The prompter just has the 20 things that you need to think about right now. And the idea is to make people less lackadaisical and less haphazard about attending to those 3 things that are, yeah, it's on my back burner, I'll get to it eventually, but I've got this really important thing to do. And so the intuition here is that nobody is so busy that they can't find, this is probably not true of everybody, but it's true of a lot of people, that they can't find 10 minutes here and 10 minutes here and 5 minutes here and 7 minutes there. And if in those 10 minutes, if those 10 minutes are used well, that they could do a quick scan of those items that require their attention and do those simple taps that say, yeah, set up a call with these guys. Yep, this is done. It's like sitting down with a secretary and blasting through a series of transactions to make sure that you're not the sticking point, that you're not blocking things that need to be blocked, and also that you've refreshed your own memory about the things that do require your attention. And for those things that require your attention, you can actually at that point make a commitment and say, you know what, I'm going to work on this for half an hour when I put my prompter away. Then you put your prompter away, and hopefully in that intervening 30 milliseconds, you haven't forgotten that you had just reloaded that task in your brain. So then you can actually do it. The next time you open your prompter, you can check it off and be proud of yourself that you did that task. So that's the rhythm. That's the behavioral model, namely intermittent engagement with a very focused session where you're doing this highly stylized transactional work against a bunch of tasks that require your attention. You do that on a frequent enough basis, and the frequency is determined in part by the needs for progress on those things as determined by the recommender engine. And there's an analogy here with operating systems. If you think about operating systems and how they schedule processes, you know, they know about resources and they know about relative speeds of things and things like that. And those scheduling algorithms that try to use processors and printers and things like that efficiently are based on the idea that the process has a will to live and a will to run and a will to complete. So you can almost think of these tasks as having a will to live, and individual brains are just a resource to it. It wants to claim some of your cognitive attention from time to time, and also the other people that are resources for this process. But who is the agency? What is the agency that is looking after the needs of the process? That is this coordination process server. So essentially, it's trying its darndest to get the process to the finish line. Okay. These other two methods here for engaging with tasks, one of them is website widget, one of them is embedded inspector. They both share in common, they differ slightly, and I'll tell you the difference, but they both share in common with the fact that they interact with exactly the same model of a task or an activity as the prompter interacts with. So if you go to a website, let's say you go to the forest management website, and the forest management website maintains volunteer groups who are working on different aspects of forest management, and you're a volunteer, so you press a little button on the forest management website that says, get involved. And the forest management website is configured in such a way that whenever anybody presses that button, it assigns them a volunteer coordinator, it tags the task as being a forest management task, it slaps a due date on, and it says, welcome, welcome, or whatever, okay? That's the configuration. But at the end of the day, after you've had that interaction on the forest management website, and you've done it in the full context of pictures of the beautiful trees and everything else that's going on that website, that task will live beyond your engagement with that website in a facility that's interoperable with your personal prompter. So at the end of the day, your prompter will say, what have you done lately for the forest management website? That will show up as one of your personal tasks. And your role with respect to that task comes from the same set of categories as it would have if you had created it directly from the prompter or from your electronic medical record system or from your university-based system or whatever. They share this common language. It's like getting an email, but here it's getting a nudge or a task representation. The embedded case is even more. In this case, you can think of the website widget as essentially providing a window into the coordination process server, which is all those items that are just tagged with forest management would be visible to you, and maybe there's a little bit of customization around that. But in the case of the embedded inspector, the idea is any third-party software that wanted to create or update tasks based on a published API could do so. So for example, if you had an electronic medical record system, and the way that these systems work today is if you need to get Dr. Jones to take a look at some patient or something, you send him a secure email or you put some notes on his progress notes. There's nothing in that structure that manages the follow-up process, that manages communication patterns among the people, that integrates with other areas of his life that also have claims on his attention, right? There's nothing like that. In this scheme of the world, you could still have your dedicated electronic management system software, right? And you could even have your secure data. I didn't talk about the secure data part, but you can even have this in some secure location that communicates through a secure API with the coordination server. But when you initiate a task that says, Dr. Jones, take a look at this, that action would be interpreted as one of the formal actions that we've said before, namely a handoff to Dr. Jones of the task, take a look at Johnny. And then if Dr. Jones clicks on it and accepts that task, then that gets integrated into his workflow with everything that that implies, the follow-up, the re-engagement, the monitoring of the frequency of engagement, the operation of the stakeholder pathways. And it opens up the possibility, although there are a lot of, in the particular case of medicine and all these other cases, there's a lot of negotiation and real-world reality and legality to be dealt with about management of secrecy, but security and privacy and so on. But in principle, you can coordinate across the ecosystem to parts of that ecosystem that aren't on your embedded hospital system, right? And that's the intended purpose behind this entire architecture. In the same way as email. I mean, you can send an email from someplace and you don't know what server the person that you're going to be reaching is on. Now let's talk a little bit about the prompter. I know this is a little bit busy. These slides are a little bit busy. These are not depictions of an actual deployed prompter that you can go and download right now, but these are wireframes to kind of give you the point. The basic, I'm trying to give you the feel of what a session is, right, and what you're doing when you're in a session. If you open your prompter and you're looking at the first screen, what you're seeing is a list of tasks. The ones above the line are the important ones. The ones below the line are also important. They're all important, but these are especially important, okay? You can get things to be above the line by tapping on them, and then they'll jump to the top there, and they'll have a little yellow star on them. And what that means is, Mr. Recommender Engine, don't swap these out. keep these top of mind. I want these to be here when I come next, regardless of what you think is important. They're important to me. If they cease being important, then I'll tap them again, and that little yellow dot will go away, and they can just go back into the general pool. If you tap on one of these over the task, it will open up the task detail, and here you can read the stream of comments, and this is pretty much what you would see in any social media product. You can basically see the comments that have come in from the stakeholders, or the history of this item if you choose history, and you can manage the details of it, and you can just flick through these with your thumb, and you can go through all 20 of these. But the intention is that you're going to get a subset of your tasks. You may have 100 tasks in the task database, right? And you may even have ways of getting them. But the recommender engine is focusing you in batches on subsets of these that require your attention at a particular point. Okay, so this is the task management. At any point in time, at the top level or the embedded level, you can push either of these two buttons. Plus task means spawn a new task. If you're inside another task, it will introduce the hierarchy that you were looking at before. If you're at the top level, it will just introduce a task at the top level. It doesn't know anything about atomic versus not atomic. There's no presumption semantically that the spawn tasks are exhaustive or complete unpacking of the original task. There's no presumption of anything like that. It could be a follow-up task or precondition or who knows what. But there is this structural relation of having been spawned from within the context of another task that's maintained internally and it's monitored. Okay. PlusCall initiates the setup for asynchronous communication. So if you say PlusCall, then you tap in the topic and you tap the name of the person you want to talk to. It doesn't try to reach them right away. What it does is it initiates a protocol by which both of you first agree that you want to have that call and who wants to be in it. And secondly, where the system tries to broker a time, ideally within the session itself. So the way that works is I say, PlusCall, I want to talk to Martin about the talk I'm giving next week. And then Martin gets that. Maybe he's pre-accepted all my calls, so it goes straight to confirmed. But if he hasn't pre-accepted all my calls, then he'll say, incoming call request from Stan to talk about the talk next week. And he says, accept. If he doesn't say accept, he can actually tap in a little message below to say, is this call really necessary? And shouldn't Fred be in on this call also? And we can go back and forth about that asynchronously for a while. But when we're finally happy with the invitees and all that, he says accept. I say confirm. We've got a call scheduled, but we don't have it scheduled. We have a call agreed upon in principle. But as far as the scheduling goes, the system has an opportunistic way of matching us up. And the way that it does that is it tries to nudge our sessions into alignment. And it does that by means of this heat map, right? This representation of expected value to me of being online at a particular time. Okay, so these peaks here represent times when it'd be really good for me to be online. Where do those peaks come from? Well, one measure I just mentioned is CoAvailability. So if I have a dozen agreed upon calls with various people, and they've already confirmed, and the way you confirm is just by tapping to the right, and that gives you a little green bar. Like I agree to be online at that time, right? The system knows that I only have a 60% chance of showing up because I'm a regular no-show, right? But it can fold that into the expected value calculation and come up with a number that represents what the value to me would be to be online at that particular time based on the expected show-up of the people that I have agreed calls with, right? Plus the value to me of talking to those people as indicated by their rank order in this list over here. So you have to actually impute a number from the ranking. That's not necessarily easy, but there's something reasonable that you can do there. And that all gets folded into this calculation. The other thing that gets folded into the calculation is unblocking. So if you've asked me to do something and I haven't accepted or declined yet, and you're going to show up at 2 o'clock, and I can unblock you at 1 o'clock, I've created social value to you. And I'm part of this community, so it's created value for me as well. And that can be part of the calculation. So the system can be trying to jointly optimize for throughput within the system by noticing these dependencies and trying to get me to unblock as many as I can. And the third thing is that the system is trying to optimize the frequency with which I engage with tasks on a batched basis. In other words, the rate of engagement with the prompter, the session manager, represents kind of a carrier pulse on which all these other pulses are going to be subdivisions, if you will, right? So even if there's a task that I need to look at every single time that I'm using my prompter, every time that I'm in session, that frequency is only going to be as frequent as I engage with my prompter. unless we have some kind of external interrupt mode where just my prompter goes off like crazy and says, Stan, you got to look at this thing right now. It's urgent. Right? You could imagine building this out to accommodate those special interrupts, but they would be the exception rather than the rule. The general rule is you have 100 tasks. Some of them need to be looked at a couple times a day. Some of them need to be looked at every few days. But there is this heartbeat. There's this rhythm. And the rhythm doesn't necessarily mean equally spaced intervals, but there's something about the rough rate at which you engage with the prompter. And the way that the system can influence that is by not preempting your right and your autonomy to decide when you open your prompter, but by influencing you to engage enough times by putting out enough peaks here. And that's intended to remind you to check in frequently enough. People have often asked, well, should this be integrated in with people's calendars? The general thought is that that may or may not be productive. It's something that can be looked at later. In general, people's calendars may not be fully informative about whether they have 5 minutes to look at a prompter. They can be sitting in a meeting going like this and using their prompter, or maybe there's a coffee break in the meeting. So you may not have deep enough domain knowledge of what people do in meetings to be able to use their formal Google Calendar as a guideline to when to space these particular sessions. But it could be useful for other kinds of conventional meeting scheduling protocols that could be layered on top of this later. Okay, enough on this. I'm going to mention 2 extensions, and then I'm going to return for a second to some of those application use cases and talk a little bit about what we're doing about that. So one I mentioned earlier was templates. Now, the idea of templates, is a very conventional idea. The thing that's kind of an interesting research question here is, how do you kind of share initiative with a community of actors that has access to all of the operations by which these networks and the activities that they inspire, right? They have full control over the shape of that social task graph, right, at runtime, right? The owner of a task can basically declare that it's done and get rid of it. They can add new stakeholders. They can initiate transfer of ownership. So that entire topology is completely transferable to the people who are executing the template. And yet the template can be an initialization that offloads a lot of the kind of the head scratching about what should we do about this thing, and provides a starting point for those activities by assigning some default actions, some default owners of those actions, and pre-wiring some stakeholder relations so that with a single click, the owner can essentially deploy that entire cluster. And you could parameterize that thing so that it's it's literally a template. It's a script that has slots in it. You fill in those slots with people's names or even activities, specific activities in some cases. And then it macro expands, essentially, and initializes that piece of network that represents that shared set of commitments. None of the subsequent operation of that thing, and even that first step, violates any of the architectural principles that we laid out before. Nobody gets forced to do anything. In other words, if somebody is assigned a particular task in that template, they will first see it in their prompter as, hey, can you do this thing? And they need to say yes or no, right? If they can't do it, then they should tap a little note in that says, gee, I think Elizabeth should do this one, right? Because the subsequent execution has all of the flexibility that the underlying paradigm has. But this is what templates are, okay? The second extension is including artificial agents in the task network, and people talk a lot about hybrid agents. And this is really an important distinction to make because we're all familiar with personal assistants and Siri and all that kind of stuff. There's a whole category of agent software which is meant to be personal task assistants. For many of them, they are really intended to be domain experts. They really know how to things like, book some travel or choose you a good restaurant or something like that. They really know something about the domain of operation, and you're trying to offload an actual real-world activity, okay? And in a sense, that's what these agents could be if they got included in this task network. If you look at the recommender agent and the prompter, they're not really dealing with the real world because they don't know anything about pizza and air travel, right? The recommender engine in the architecture that I showed you earlier only knows about owners and tasks and, and how recently you've seen it and how many touches it has and things like that. It's all structural knowledge about the process, nothing about the actual real world that this process signifies actions about, right? So where does that kind of expertise live? Well, the proposal here is that those agents be included in the network as first-class objects, Namely, you would have a little SDK, you put a little wrapper around a piece of software, and then it interacts with the coordination server the same way as a person would. So when it completes a task, it checks it off. When it posts a comment, it posts it to the same stream as the humans are. So for example, if you included the blood pressure reader as a stakeholder on your medical task, then the blood pressure readings would appear as comments in the comment stream, and the human doctors could have a conversation around that. Okay? So it's meant to unify the model and the interfaces to the artificial components of the system around natural conventions that humans might have when coordinating with themselves, and it should make it interoperable. So when you take over from the nurse who was posting those comments about blood pressure and you turn it over to the machine, that's not a big discontinuity in the system from the point of view of the other users. Okay. And then finally, I want to just say a word about this molecules of guided activity. And the idea here is that one of the motivating uses for this open architecture for coordination is to try to take areas of activity that are where there's a lot of goodwill and a lot of motivation for people to do things together, but there's not a lot of coordination literacy about how to make them happen, right? So if you think about all those areas that I mentioned at the beginning, healthcare and so on, if you look at the institutional actors, they're on board, they know what they're supposed to do because it's part of their job, right? They're all trained to do that, they're all using specialized systems to do that. But if you look at the other half of the players, right, that they're reaching out to, so for example, an NGO might be dealing with a community of well-wishers, and that community has a lot of goodwill. They really want to help out with forest management or whatever it is they're supposed to do. So either they join a committee and they come in and spend time with people and they're really deeply into it, okay, in which case you can enforce a set of, a culture around that. Or what? You send them an email and say donate money, or, send a letter to your congressman. So the idea here is you can actually deploy clusters of activity that have more structure to them and have more of a life cycle to them and have more organic breathing room in many of these areas and tap into a lot of social good and a lot of action potential, energy and intellect that people are willing to invest in doing lots of good things for a lot of people. And if you look at each of the areas, and in fact, let me just jump forward here. We're actually starting circles of interest, or actually a single circle of interest that's trying to look at these different areas from the point of view of what would the world look like if we had this ubiquitous coordination technology and a high degree of coordination literacy in the community at large. How would each of these areas and specialists in them view their world differently? How would the ecosystem around a patient look differently? How would the ecosystem around a student look differently, or look different, if you were living in a world where this happens? So if you go back to that first slide and you talk about any of those problems that I mentioned, like kid dropping out of school, and you ask the question, what could have happened differently, and who would the stakeholders have been, and what actions would they have taken, and how would they have known that that was the time to take those actions? And you kind of back it up and turn that into a little template and deploy that template among the stakeholders involved as part of their being helpful to each other. Not necessarily all going through the guidance office of the school institution, right, or the professor, right? It's the whole support system around the student or around the patient or whatever, and their collaboration, their interactions are managed in the same way as every other thing in their life is managed in this view of things. It's just like sending an email, basically. It's that lightweight. So that's the idea. And the idea of the social process design as a force multiplier is you can envision processes by which bits of social network are built out as kind of molecular structures, right? I went through in great detail what the atomic operations were, right? But when you build out those atomic operations, what you're building out is a structure, and pieces of that structure, little subclusters or subnetworks, really represent useful social objects, if you will, social structures that support some set of activities and may be used to do kind of early monitoring or problem avoidance in certain areas that actually affect people's lives by bringing more social context to bear on them, and also by bringing a little bit more process knowledge, and also by bringing a little bit more proactive triggering of behaviors in a social context that will help people do more, better, good things, right? You get the idea. So anyway, that's what I wanted to say. And And I'll just leave this slide up here. It's kind of to provoke some discussion. And ready for questions? Yeah.
Makes me think about a long history of project management tools that work very well in structured environments, and when the environment is slightly less structured, they sort of all fall apart. And one of the factors is that the amount of energy that it takes to put in the elements that represent the intentions change as a result of some exogenous thing, startup, right?
Right.
An important aspect of what I would do would be to have awareness of progress around me and things that would suggest it's time to rethink, right? Rather than just being like the Japanese soldier on an island who didn't know that the war was over and continued to fight it. So I'm interested in your thoughts about this balance between the time invested to put together and to create something that would then drive behavior versus the dynamic nature of some work environments.
Correct. And I think that, in a lot of these project planning systems, the planning is done by the project planner, somebody who's skilled at project planning, and it's done at the beginning of the project. But it's only done down to a certain level. A lot of the execution details and all the communication paths around them and all those particular events are kind of left to people's natural abilities. They're dealing with a persistent group of people that they deal with a lot. They're dealing with in an environment where they've got enough time to invest in it and so on. Those are very particular assumptions. If you're in the open internet, those assumptions may not hold. But what I will say this about the walking the line between structured to overstructured and understructured. What we've tried to do here is we've tried to carve out the smallest number of concepts that would provide enough structure to keep activities moving forward, where the ambiguity about what was required next of you is minimized, and all the kind of intelligent human knowledge that you have about the actual task is left to you. It doesn't try to second guess you about those things, right? And it gives you full ability to use the informal channel to fill in the rest of the details. So for example, we had this, I'm doing this task, but the task is defined by a text string, and you're the stakeholder, so you and I decide what that text string means in terms of are we done or not, right? There may not be an objective test for are we done or not. That's a conversation that you and I need to have, so that the architecture will support us having that conversation, right? And what it will do for its part is maintain the list of current people who are in that conversation, so that it saves me the effort of pulling up my email and doing a new CC and so on. I can just tap in a message. The habits that people have started to develop just from using communication tools, many of those are transferable into this world. So for example, Twitter has trained people to to be crisp, right? And to communicate succinctly in short strings. Well, that's really helpful in an environment like this if you're just trying to boil it down and get to the bottom. Like, what are you asking me to do? What do you want me to do? Do this thing. You have some more notes, write in some more notes, but do this thing. If you have a short comment or an update or whatever, you can expect that people will be able to manage that level of terse communication. The idea that people engage with their smartphones repeatedly, right? Maybe too often, right? But we want them to have the habit of not just letting everything slide for a week and a half. We want to have some rapid enough turn rate that we can layer these other frequencies on top of that fundamental frequency, if you want to think of it that way, right? So that's actually a useful habit that people have. So anyways, we're going to keep it informal, but just put enough structure on there to let people make progress. Yeah.
And if I may ask, sorry.
Yeah. I'll come back to you in a second. Let Martin get this question. Correct. Mm-hmm. Mm-hmm. Right.
Email tool.
Right.
Get thing text I can display at the same time.
Correct.
Made it very difficult at a time to enroll other people. Have you done more thinking about that?
Absolutely, and I think that was really the impetus behind the open architecture, because that was basically a closed system, and there are 125 social task managers out there. Go to Wikipedia and look up task manager, and you'll see 125 things, and they're all fighting with each other. And if you take all of humanity collectively, that probably less than 5% of the people on Earth are using any of them, right? So the idea of having an open architecture that integrates with other touch points right, like email systems, scheduling systems, and so on, but maintains a common language for interoperability, right, so that whichever of these entry points you approach an activity from, you're getting a consistent picture of where that activity is in terms of its state of completion and who's involved with it and what its status is. Well, if the email system, so there are two ways that can happen. Either the email system has some kind of plugin architecture and you can arrange for that to happen, or you have, in some cases, you actually have to work with the software developers to get them to integrate an API at that level. And particularly for people who actually are committed to a particular task system like Basecamp or Asana or one of these things, the same issue. But if Asana ever wanted to get outside of the particular project team, I mean, maybe they believe that everybody on Earth is going to use Asana eventually, so that's their proposal for the universal architecture. But if they want to be that, then they have to. Right. I think it gets down to, you know, if you're going to design this from the point of view of what is the life cycle of a task from the point of a gleam in somebody's eye, I have the intention to do this thing, to the point where it's closed out and I have finished this. If you consider all of the interventions that might need to happen on the way and the places where that thing could get stuck because somebody's not paying attention to it, you need ways in which you can grab that person's attention consistently so they move that thing forward. And that was the idea behind the prompter, which is not to say it couldn't have happened by emails. The problem with emails is they're too atomic. You know, they don't cluster and they don't batch, and there's no model for how you engage with email that has those predictable, reliable periods of batched engagement. Yeah. Okay. It looks like you have to go. So, oh, we all have to go. Okay. Okay. Well, I'll take one more question in case anybody has one, just in case. Yeah. Mm-hmm. 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 Yeah. Mm-hmm. Mm-hmm. Right. Right. Yeah. 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 Well, the 24 hours is not a magical number. And yeah, I mean, the general framework is parameterizable. I mean, you could have these be small intervals or large intervals. That wouldn't really matter so much. What matters more is just the social conventions around people's expectations. So if I use the system, but the same is true with email. If I send you an email and you don't get back to me in 3 weeks, am I right in sending you another follow-up and say, hey, did you get my first email? I didn't hear back from you. People are running these little timers in their heads all the time and trying to decide, should I poke this person? Should I ping this person? Should I get my status update from this person? Because there is no set of conventions by which you can reliably establish some kind of rhythm of interaction. And that is a limiting factor and a piece of frictional drag on people's ability to perform complex coordinated processes. Because if I have to wait 6 days to get a 5-minute answer from somebody on an email, you can see what that does to the rate of any coordination that we do. So a lot of these hypothetical things that we could do in all these different areas fall by the wayside because you don't get any kind of reliable response. So the idea here is to get around that problem from people who are willing to do that, you know, and I guess it's just a hypothesis that there will be a lot of people who are willing to trade off some amount of stylized interaction for freedom, in essence, to know that they don't have to worry about these things. Once they put them in the system, the task will come back to them. at some interval, they can always say, no, can't be bothered with that. But at least they're going to see it, and there are going to be a few taps that they can do that will move the thing forward at that moment. If it's a long-term project, every project has a next step. I mean, projects ultimately are just sequences of mental and physical events, right, on the parts of all the participants in the project. So even if there are 10,000 of them, you do them one at a time because you're pretty much a serial processor. And all this is doing, you decide what the next step is. This is just reminding you, hey, you're writing